Let's look at one more example in this section. And we're going to ask something a little bit differently here. Find the absolute minimum and absolute maximum of the function. It's going to be x squared plus 4y squared minus 2x squared y plus 4 on the rectangle given by x is between -1 and 1, and y is between -1 and 1. So the first thing we're going to do is we're going to picture this region, this rectangle. We're going to look at these two conditions here. So the rectangle that we're looking at is this region right here. Okay, so now that we can picture our region, the next thing we're going to do is we're going to find the critical points that lie inside the rectangle. So in order to do that, I need to look at my function, and I need to look at my partial derivatives. So fx will be 2x minus 4 times xy, and fy will be 8y minus 2x squared. These are polynomials, so they're always defined. Now, I'm going to look at the system of equations where I set these equal to 0. So there's my system of equations. And what I can do is I can solve for y in the second equation here. If you solve for y, you'll get x squared over 4, and then plug this in to the first equation. So we'll get 2x minus 4 x times x squared over 4. So here I'm going to get 2x minus x cubed equals 0. I can factor an x out, and I get x equals 0, and then x equals plus or minus the square root of 2. But remember that the square root of 2, it's 1.414, right? And this x coordinate, this lies outside of my rectangle. And we're only looking for points, critical points inside of my rectangle. So here, if x is 0, if we go back to our equation for y is x squared over 4. So if x is 0, then y is also 0. So we get this critical point. The only one we have inside of our triangle, or inside of our rectangle, is 0, 0. So I'm going to plug in my critical number into my function, and my function would spit out 4 if x is 0 and y is 0. So we're going to want to remember that value here. And now what we need to do is look back at our rectangle here. All right, our rectangle is made up of 4 sides. a left side, a right side, a top, and a bottom. And so we're going to describe each one of these sides. So let's start with the right side. How would I describe that? Well, x is 1, and y is between -1 and 1. And then how would you describe the left side? X is -1, and y is between -1 and 1. And then we're going to describe the top and bottom now. So the top, y is 1, x is between -1 and 1. And the bottom, y is -1, x is between -1 and 1. So now we need to look at each side of the rectangle individually now. So we're going to start by talking about the right side. X is 1 and y is between -1 and 1, and we want to see what's the maximum and minimum value of my function on the right side of this rectangle. So you're going to take, since x is 1, go back to your function and plug in 1 for x. And now you really just have a function of a single variable. So I'm going to relabel this. Let's call it g. It's going to be 5 plus 4y squared minus 2y. And what you need to do is you need to find the absolute extrema on the interval -1 to 1. Because that interval, that's what y is between, -1 to 1. So we're going to find the derivative of this equation. This is 8y minus 2. Set that equal to 0 to find our critical number. Y is 1/4. So you're going to plug in 1, your two endpoints. If I plug in 1, my function is 7. -1, your function's 11. And then plug in your critical number 1/4, 19/4, or 4.75. So you're going to also want to remember we still have our number from earlier. This f of 0 was 4. Now you want to look for the maximum here, which was 11, and the minimum, which is 4.75. And now you're going to repeat this. We just did it for the right side. Now you're going to do it for the left side. So the left side, x is -1, y is between -1 and 1. So you're going to plug into your function f -1 for x. And if you see here, you have the same function that you had earlier. So we already know the critical numbers. We found them earlier. Our critical number was 1/4. So this is the same as earlier. So I plug in my endpoints into my function g now. You get 11 and 1/4 is 19/4. So here's my minimum, here's my maximum again. And now you're going to repeat again this for the top side. Y is 1, x is between -1 and 1. So now you're going to plug in 1 for y. And now we get a function with just x in it. I'll call it h of x, which is 8 minus x squared. X is between -1 and 1. Find our critical numbers inside of that interval. We get x equals 0. So I'm going to plug in h of -1 is 7, h of 1 is also 7, h of 0 is 8. So my minimum value was 7, my maximum value was 8. And finally, you're going to do the bottom side. Y is -1, x is between -1 and 1. So you're going to plug in -1 for y. If you do that, you'll get 8 plus 3x squared. Find your critical numbers. I'll relabel this as my function h of x. H prime of x would be 6x. My only critical number is x equals 0. So plug in my endpoints into h. And now what you're going to do is you're going to compare all of these values to see where did I have my maximum value and where was my minimum value. So out of all of these values, my smallest value was 4, which occurred at my critical number. So my absolute, you're going to compare the values, and I can say that the absolute minimum occurs at 0, 0, and the value that's the minimum is 4. And now if I look for the absolute maximum, the maximum number I got out, if I look back at my list of numbers here, was 11. And then occurs at which point? So I got to go back through. So I get the point 1. X was, so from here, these, x is 1, y is -1, x is -1, y is -1, and I think you get the same points up here. Yep, x is 1, y is -1, and yeah, and the same thing here. X is -1, y is -1. So here are my absolute maxes and mins right here. I have an absolute minimum that occurs at one place at the origin. The minimum value is 4. And I have an absolute maximum. It occurs twice. My largest value is 11.